Hey there, this is Anthony from iCodeTeacher.com. In this lesson, we're going to create a basic graphing application on the iPhone. So we'll make an X and Y axis, and we'll allow you, the developer, to input some function, and based on the function inputted, the iPhone will output some graph onto the screen, covering the entire range of the screen. So from 0 to 320 on the x-axis, and from 0 to about 460 on the y-axis. So let's get started. So of course I have Xcode open, so let's create that new project. We're going to go window-based here. It's going to be a pretty simple application. All we really need is just a view for drawing on. We'll call this graph. And now the first thing we need to do is we need to create a view for doing the drawing in. So we're going to be doing all of the drawing in code. We're going to be using some core graphics functions here to create some lines, move to different points, and connect everything, and basically draw. So let's create that graphing view first. So select classes folder here and just create a new file. It's going to be a subclass of UI view. And to keep it simple, we'll call it graph view. So if we go to the .m here, there's a method called drawRect. Any UI view object, when its view gets output onto a screen, it tells itself to execute the code in the drawRect method. So you can, as you can see with the comment here, you can do your drawing code in here. So any drawing objects, whatever subviews that you want to add onto the screen, whenever this is displayed, this view is displayed on screen, you can do that in here in code. If you're not going to do this in Interface Builder, and that's what we're going to do. So we're going to put a bunch of drawing code right in this method here, and it'll get called automatically when this view is displayed on screen, or in other words, when the application launches. We need to actually, though, create an instance of this view and add it to the window. So we'll do that in Interface Builder. So let's open the resources folder here and open mainwindow.zib. And now let's add that graph view onto the window. So let's open the library first. And we're also going to need the identity inspector. So if we scroll down a bit here on the bottom, we've got UI view object. So we're going to drag that right into the window here. We'll let the Interface Builder resize it. And now if we select this view and go to the identity inspector here, again, of course, if you don't have that open, you can go to Tools, Identity Inspector again. So we need to make the class graph view. So we don't want this to be a generic UI view object. We want it to be our own subclass of UI view, which again is graph view. So we can click the drop down here, and it's already listed for us. Interface Builder is very smart. Select graph view, and now we have created an instance of graph view, and it is sitting pretty right inside of this window here. So now we're done with Interface Builder, and we can just get to all of our drawing code. So I'm going to close this and get back to Xcode. So the first thing I want to do here is I want to create a function simply called f of x, as you would in any generic math class, where the function will take one input value, x, and provide an output value, y. So let's create that function here. So float f, float x. So again, this is function, the name of the function is f, and it takes one variable x. So if we were to get rid of the float types here, it would look like this, which, if you've taken a math class, you've seen this 100 million times. Basically, we're stealing that right from the convention. So we're going to start off with a really simple function. Our function is simply going to be y is equal to x. So for any given x, y is equal to that x value. And if you're familiar with the graphs, you know that the graph y equals x is simply a 45-degree diagonal line that runs from the bottom left, has a slope of 1, and runs 45 degrees right up towards the top right corner of the bounds of the graph. So that's what we should expect to see when we're finished here. We don't need to touch init with frame. We're doing all of our drawing in DrawRect, which again, as I mentioned, is automatically called. So the first thing we need to do is we need to get a drawing context. A context is basically a location in which this drawing should be outputted. So you do some drawing, you need to tell the iPhone where all this drawing is going to go. So let's get that graphic context. So we expect the graphics context basically to be this view. So CG, we have a type here, CG context ref, which stores a reference to the graphics content, graphics context, excuse me. We'll call it context equals, and then we have a function here. As usual, Apple makes everything very simple for you. UI graphics get current context, and that gives us the graphic context. So you can do this pretty much from anywhere. Basically, it's just one obligatory step. You can draw in different graphics contexts if you happen to be dealing with multiple graphics contexts or creating your own. But this is really simple, so we're just going to go with the one that that Apple knows we're probably going to want to draw in, which is going to be the default view here. We're going to set a background color for this view. Again, remember, we're doing this code inside of graphView.m, so self here is simply the graphView object. So we're going to set the background color to white, just to make things easier on the eyes. Okay, now I want to mention now that as is often most of the time with iPhone SDK programming, this is one of those situations in which the basics are simply memorization. You know, there's just a way that things are done here. This is the way the Apple developers have come up with. You have to memorize the steps that they've come up with, and there's these, you know, obligatory steps you'll do every time you want to, for example, draw in a view. And once you've got the basics down, you can start messing with it and modifying it to fit each individual application you make. But the basics are always the same. So a lot of this is just going to be just the way it's done. You know, there's no real reason for it. It's just the way the Apple developers have designed the Cocoa Touch API. And then we're going to see a lot of that here. All right, so we've set the background color to white. Now we need to do something here called setting the drawing color. So let's take a look at the documentation here. Look up UI color. And we have here a method set. It's an instance method. Pay close attention to that. So we're first going to have to create an instance of a UI color object and then send the set message to it. So if we read the documentation here, it says, sets the color of subsequent stroke and fill operations to the color that the receiver represents. So what this means is when we set a color, whether it be black, white, gray, red, anything in between, any drawing or filling that we do after that set is going to be in that color. So we want all of our drawing to be, well, we want the drawing for our graph to be black, but we're going to make the color of the axes gray. Right? So right now, let's get the axes out of the way, the y-axis and the x-axis. Let's draw those first before we get into the harder part of this, which is actually drawing the graph that can vary depending on how you change this function here up the top. So we want to set a gray color. So first we're going to create an instance of a gray color by calling to the UI color's gray color class method, and this simply returns a UI color object that stores the color gray, and then we simply say set. So now any drawing, stroking, or filling that happens after this will be in the color gray. Alright, so the first thing we need to do is we need to actually create the path, the line, the stroke, whatever, that we're going to be adding lines to and everything. So we're going to start off by creating a mutable CG path. So CG mutable path ref. We're going to call this curve path. It's not always going to be a curve, but we're just going to call it curve path right now because it can be a curve. CG path create mutable. So again, just another really simple Apple created function. All it does is just create and return a reference to a mutable core graphics path. And we can use some other functions to give this path some lines, move it around, and it's not very hard to do at all. It's just, again, memorizing the steps to do it. So next thing we want to do is we want to move this. We don't want to move the path, the starting point of the path, to a point on the screen that we can do some drawing from. So we need to move this path, which currently is empty, to a point that we want to start the drawing from. So with this path, we're going to create the y-axis. So that'll be going vertically, so up and down from the top of the screen to the bottom of the screen, right in the center. So first, we need to move this path, the starting point for this line we're going to draw, to the center of the screen all the way at the top. So it's good to mention now, if we go back to main-window.zib, and if we say this is the iPhone screen window here, most of the time, especially when you're dealing with math, any math course, calculus, pre-calc, anything like that, even trigonometry, the starting point for a graph is always the center right here, the origin, 0, 0. The origin 0, 0 will always be right in the middle of your space that you're drawing in, right? But with the iPhone, the point 0, 0 on the screen is actually this top left corner here, right? So we're going to have to do a bit of shifting and some reflections almost to get the graph to look the way we want it to, basically to make it appear as if the origin's in the center here. But for now, note that the point 0, 0 is up here, and so as you move to the right, the x values get greater, and as you move down, the y values get greater. So 0, 0 is in this top left corner, and the bottom right here is the coordinate 320, 480. So that'll be 320 across, 480 down. But again, it's positive. There are no negative coordinate values when dealing with the iPhone screen. So again, we can close this. Now we have that in mind. Let's move our path to a point that we can start the drawing from. So we have a function here, again another obligatory function, cg path move to point, and now the first parameter is the path that we want to move to the point that was going to come after. So we want to move this curved path to the point. The next parameter is a CG affine transform reference. Affine transforms are ways that you can scale, rotate, basically any transformations you want to do with your graphing or drawing. We're not going to be doing that. It's going to be a flat graph. So we're going to have null here. And then so again, we're drawing the y-axis with this path. So we need to start in the center. So that'll be self-center x, which will also be the point 160. Again, self is the graph view. It has a property center, which is the center of the screen, and then the x enum value will be 160, and then again 0 for the y value, because again we need to start at the top middle of the screen. So center the x value and set the y value to 0. Now we're just going to draw a vertical line straight down to the bottom of the screen. So we have another function here, cg path add line to point. Pretty obvious what this function does. Simply starts it starts from where you last moved the curve to, which again here is the middle of the screen at the top, and then it's going to draw a line to the point that you moved to. So cg path add line to point. Again, the first parameter is going to be the path that we're actually adding the line to. The next parameter is going to be also an affine transform. We're not using that, so no. Again, self-center x, that's not going to move. This is a vertical line, so it's going to be right in the middle all the way down. And then here, we could put 480, but I'm just going to put self-frame size height, and that will return the height of the screen. In other words, the bottom of the screen. Again, because I mentioned that the y values start at y value 0 is at the top of the screen, and the value 480 is at the bottom of the screen. So 480 is the height. That'll also be the coordinate of the very bottom of the screen on the y-axis. All right, so now we need to add this path to the graphics context. So we have another function, cg context add path, the context that we're adding this path to, and then the second parameter is the path that we're adding. So now we've added this path to the actual graphics context, or the screen, basically, if you think about it intuitively. Now we want to actually stroke the path, so we have another function here, also another obligatory function, cg context stroke path. This will actually basically make the path visible in the color that was set earlier. So in this case, it'll be gray. Context, we plug in context, so this will fill in the colors for all the paths and objects that we've added in the context. And then we want to release the curve path. We're done with it. We're going to release the path, not to avoid memory leaks. Now we need to do the x-axis. So let's get on that. So the gray color here is fine. We're still we still are doing the axes, and so we want those both to be gray. So we don't have to set gray again. The setting of a color will remain for the duration of the method, or until you set a different color. Okay, so we want to create a new path again. So a lot of these steps will look the same. So path, create mutable. Want to move to the point. This time we're going to be all the way on the left of the screen, but halfway down. So basically these two will be switched here. We're going to use self-center y and 0 for the x value. So curve path, null again for the transform, 0, and self-center y. We need to add the line to the ending point of this axis. So again, it'll start at the left of the screen and it'll span all the way and end at the right of the screen. So cg path add line to point. So first thing, of course, is the path reference, then null for the transform. And then this time, we're going to set the x coordinate to the width of the screen, which is 320, but I'm going to do self.frame.size.width. And then, again, the y value here is not going to change, so self-center y. And the rest is the same. Context, add path, context, curve path, same as before. And we want to stroke the context and fill in what we've done here. And then last, release that path. So let's see what we've got so far. Okay, so basically what we wanted here. So we've got the axis, the y-axis going from top to bottom, and the x-axis going from left to right. Now, if you notice here, the x-axis is not actually in the center of the screen. The reason for that is the status bar on the top there, which is exactly 20 pixels high, is pushing everything down, so to speak, in that the view here, the graph view, is starting 20 pixels lower, but we're graphing everything as if it starts from the very top of the screen. So we have two options here. We can adjust everything by subtracting 20 from each y value we get here, or we can hide the status bar. I'm going to go with the former. I'm going to subtract 20 from the y values. I imagine that a lot of you, when you build, if you build the graphing applications, you will want to keep the status bar there. I always liked the status bar. I thought applications, unless it's a game, I always thought they looked a little silly with no status bar, so I'm going to leave it. Of course, that's all personal preference. But so we need to go here, and instead of self-center y, we're going to have to do self-center y minus 20. So shift everything up 20 pixels, and the same thing here. Now if we bold it, you can see that it's definitely much more centered this time around, or it appears to be. So we're going to have to do that with all of our y coordinates from here on out, but I don't find it to be a big deal. It's simply a shift. It's not very hard to understand. It's just something you have to keep repeating. So we now have the easy part out of the way. Now we can get to the hard, but also the fun part, where we actually graph the entire, we fill in the graph as per the function defined, or we graph a function. So I'm going to do that after putting in the axes here. So the first thing we want to do is we want to actually set the color of the strokes to be black, so it's more vivid in comparison to the axes. So UI color, black color, set. And now we want to begin by creating our path, as we did the other times. CG mutable path ref graph path, so we're going to make a new reference here, equals same function, CG path create mutable. Now I want to mention early on here, we're going to have to actually split this graphing in two. With traditional math, when you do some graphing like this, you'll start at some negative values and you'll go all the way to your ending positive value. So if your graph has if it ranges from -5 to 5 on the x-axis, you'll start at -5 and then you'll graph -4, -3, -2, -1, 0, and then 1, 2, 3, 4, 5. Here, because of the fact that the iPhone's origin is not actually in the center of the screen, but in the top left corner, we need to move to the middle of the screen, graph the first half from 0 to the right end of the screen, and then we need to move back to the center of the screen and graph the second half from 0 to the left of the screen. And we're going to have to do some adjusting for each of those. So let's begin by moving to the point 0, 0 on our screen here. So CG path move to point graph path, again null for the transform, self.center.x, and then self.center.y minus 20. Again, we're going to have to subtract 20 from the y values each time from now on. And now we get to the really fun part. We're going to actually use a for loop here. So what we're going to do is we're going to basically add 320 little tiny lines on our screen. So we're going to graph, we're going to find we're going to start with an x value of 0. Then we're going to find the appropriate or matching y value for that, right? And then we're going to start there. And then we're going to draw a line to the point 2, comma, f of 2. Then we're going to draw a line to the point 3, comma, f of 3, and so on and so forth. So when this is all said and done, we're going to have 320 really, really small lines. But they'll be so small that even if we draw a curve, it'll still appear to be a curve. You won't be able to see the lines just because they'll be so small. And so let's make that for loop. So for I equal to 1, I is less than or equal to 160, I plus plus. So again, we're starting at the center here, and we're going to go all the way to the right. So we need to keep in mind that we want our graph to appear as if the origin is the center of the screen, but for the iPhone, it's actually the top left again, as we mentioned multiple times. So in this for loop, we're going to actually pretend that the x value in the center of the screen is actually 0 and not 160. So we're starting at a 1 here, and so we're going to make a float x value here equal to simply I. So when we're on the screen and we're in the center, the actual point, as far as the iPhone is concerned, is for the x value point there is 160, but we're going to pretend it's 1. Okay, so then we're going to draw a line here, CG path add line to point, curve path null, x plus self.center.x. So now here's where we take into account the fact that we are actually at the point 160. So in this loop, we're saying that the starting point, the origin, is 1. The x value is 1. But when we draw the line here, we're actually we're starting at the center of the screen, x center, y center, and then when we draw each individual line, we're going to add 160. So when we're drawing a line at x value 1, we're actually going to add 160 to it, so it'll be 161. 2 will be 162. I'm sorry. Yes, 3 will be 163, and so on and so forth. So it's basically just an adjustment here, some calibrating, so to speak. And now f of x plus, same thing, self-center y, and then minus 20. Okay, now we can close this for loop, and then CG context, add path, context. Oh, actually, this needs to be graph path. We're not dealing with curve path anymore. Graph path. We need to stroke the context, stroke path, context, and then we can release this graph path here. So let's take a look at what this looks like, and we should expect to see a problem here. But let's look and actually see what. Oh, I need this to be into I. For that. Okay, so now we expected this, since the function here is f of x is equal to x, or y is equal to x. This diagonal line here should actually go up like this. Now the reason it's not is because, as we mentioned earlier and multiple times, for the iPhone, positive x values actually go down. So 0 for positive y values go downward. So 0 for the y coordinate here is in the top, and 480, positive 480, is all the way on the bottom. So to fix this, all we have to do is negate all the y values. So when we find increasing y values, we actually want to negate those so they become decreasing y values, and vice versa. So we're basically just flipping the graph about the x-axis. So we can just stick a negative in here, a minus, and that should fix it. And then we have it. And so for the left part of the screen, we'll do the same thing. We'll simply negate it. So anywhere there's positive, it'll become negative, and vice versa. Let's quit this, and now we want to do the left side of the graph here. So enter twice here. Okay, so now we need to move back to the center. So let's do this actually before we release the graph path here. CG path move to point, graph path null, the center again, self.center.x, and self.center.y minus 20. And now let's fill in the lines, the little fragmented lines for the left part of this graph here, the negative x values, as far as our graph is concerned. This time we're going to start at 160 and go backwards. So we're going to set I equal to 160, and so we're going to check we're going to run the loop for as long as I is greater than or equal to 0, and then we're going to subtract 1 from I each time. And this time we're dealing again with the negative x values. So x we're going to set equal to I minus 160. So when I is 160, we'll get 160 minus 160, and we'll be at the point 0 for x. When I is equal to 159, we'll get 159 minus 160, and we'll get negative 1, and so on and so forth. So now we need to draw that line. So CG path add line to point graph path. Again, the path we're adding the line to. Null for the transform. Again, we can do addition here because the x values, as we move to the left, the x values get increasingly negative. So x plus self.center.x. So the same kind of calibration here. And then the same thing here. Negative f of x plus self.center.y minus 20. And we can close this. And now we can launch application, take a look at see what it looks like. Alright, so as we hoped, we have the graph of f is equal to x. There's a few more things I'd like to do here. So first, let's play around with this function here. So let's try the graph of x squared. So x times x, and let's see that looks right. Okay, fortunately that looks correct. Let's try x times x times x, the graph of x cubed. Hopefully if you're watching this, you've taken some math classes, you know what that's supposed to look like. Now, when you zoom very far out, this is what this graph will look like, but maybe you want to see this closer up. So let's zoom in a bit here. And we can do this pretty easily with some multiplication and division. That is to say, if we go to our for loops here, right now, the graph is on a 1-to-1 scale. So when x is 1, f of x is f of 1. But if we want, we can scale this by any factor just by dividing the x value when we give it to the function and then multiplying that to scale it upwards. So let's do x divided by 20 and then let's multiply 20 by that. So when x is 1, we're actually going to do f of 1/20th, but then we're going to multiply that value by 20 so that it scales it upwards so it actually doesn't look distorted. It'll be stretched out left to right. Now we need to stretch it up and down by multiplying by 20. So let's take a look at this now. All right, and you can see it's almost as if we actually zoomed in here. We can do this as much as we want. So let's try 40 here. Zoomed in a little more, and it's still smooth again because not only did we stretch it left and right by dividing each x value by a constant 40, but we also stretch it 40 upwards and downwards by multiplying by 40. And so this is actually, this is what the graph would appear like if you actually zoomed into the graph. Let's change this back to 20. And let's try some other functions. Anyone who's into trigonometry is probably going to try something like sine of x. Let's try tangent of x. I'm a big fan of the way tangent appears on screen. I like how it heads off to infinity in different levels here. I always thought that was very cool. And one more, if you're really interested, we'll do 1 divided by cosine x, which is also known as secant of x. I personally like that graph. Now, we have a problem at 0 here, and I'm going to change this function to make it more obvious. Let's just make this a constant 2 here. Return 2, so y is equal to 2. So for any x, y is equal to 2, so we have a line here. But now you see here, there's a black line going from 0 to 2 right in the middle of the screen. The reason for that is if we move down a little bit here, when we began graphing the actual function, you notice that instead of moving, when we moved to the origin of the screen, we didn't actually move to the beginning y value or f of 0. We actually just moved to 0. We just assumed that this graph at f of 0 is always 0. But as we just saw, that's not always the case. If you have a function where f of x is equal to 2, f of 0 is 2. So we need to actually, like we did with the for loops here, we need to find f of 0 and give that here. So negative f of 0, we need to apply the negative for the same reasons before, plus center y, And of course, since we scaled everything else by a factor of 20, we need to do the same thing here. And we can just copy this and paste it here. Now if we save this and build, we should expect that little black line to be gone. And as we hope, the little black line there is completely gone. So that wraps up this graphing lesson for the iPhone SDK. I hope you learned a lot. I had a lot of fun creating this application. I'm a big fan of calculus, actually. Not that this was very calculus intensive, but I just happen to like math in general, so I had a fun time with this video. Hope you did too. I hope you learned a lot, and I hope you tune into future lessons. Thank you very much for watching.